Good morning everyone and welcome to my YouTube channel. So here today we are going to be looking at what we are going to call domain of a composite function. So domain, just as we looked at the other video, is just the acceptable values which can be plugged into x to give you a real number. Like for example, if you have the square root of x, the domain for the square root of x is such that you must have all the values, like the square root of 0 is equal to 0. If you have the square root of 1, it will give you 1 plus or minus 1 for that matter. Square root of 4, it will give you plus or minus 2. All the positive values will have a value, but when you put in the square root of -1, in this case, this is not going to give you a real number. It will give you I, which is not a real number. Therefore, the domain of something like that, we are just going to get whatever is inside and set it to be greater than or equal to x is greater than or equal to 0, so that all the values should begin from 0, go to 1, go to 2, 3, 4. As long as it's positive, it shall always give you a real value. Therefore, we are going to now see how we are going to look at the composite functions. Though under composite functions, there is quite just a simple rule that we are going to be following whenever we are answering such a question. So we have, let's say f of x is equal to x squared. We also have our g of x should be equal to our 3x minus 4. So we have been told find g(f) of x and g(f) of x, fg of x, and determine its domain. So to find the, let's find our g. Which one? G. Let's begin with the one we are told, our g(f) of x. This means that write the function of g. Where there is x, put f of x like that. So we are going to have our g is equal to 3. Where there is x, put f of x. Then we have minus 4 like that. So the equation shall be 3x squared. Then we have minus our 4 like that. So what we are going to end up with is, we have this one is our g(f) of x like that. So now, if this is our g(f) of x, ask yourself what values. So the domain of any quadratic equation, the equation that has got x to the power 2, no matter what numbers are there, the domain is always from -infinity to +infinity. So this is the domain. In other words, all the real numbers, as long as you put them here, it could be a 0, it could be a 1, it could be a 2. Whatever value you will be able to plug in, it shall always produce a value that is a real number, regardless of the value that you have put. Therefore, the domain of a composite function is from -infinity to +infinity, to show that you are including each and every value. Let's try our fg of x. So we have our fg of x. We know that this means that write the function of f. Where there is x in the function of f, write g of x. Now we know that our f of x is equal to x squared. So our f of x is equal to x squared, and our g of x should be equal to, we are told that this is equal to 3x minus 4. So we have a 3x minus 4. So where there is f, which is our x squared, we are going to put our g of x like that. So we are going to square this because it's squared there. Then we are going to put our g of x, which is our 3x minus 4 like that, squared. So this is the same as having 3x minus 4 times our 3x minus our 4 like that. So let's multiply. So this is the same as the first number multiplies everything. So we write our 3x multiplies everything here. So we have our 3x minus 4. Then this second number, our -4, multiplies everything here. So we are going to have a 3x minus our 4 like that. So we are going to get 3x times 3x, it will give us 9x squared. 3x times 4, it will give us negative 12x. Negative 4 times 3, we are going to have a negative 12x. Negative 4 times negative 4, that will be our positive 16 like that. So this will give us 9x squared. Then we have minus 24x. Then we have plus a 16 like that. So just as I said, so we have our g f of x. So our g f of x is the domain shall be fg of x. So the domain for this one shall be from negative infinity to positive infinity like that. So all the values that you can think of, that is from negative infinity to positive infinity, they are all correct. That's the meaning of the domain, because this is a quadratic equation. Any value that you put there, it shall always work. So when we look at our b, if f of x is equal to the square root of x, so the square root of x, and our g of x is equal to, we have a 2x minus 1. So what we have is that find f g of x and determine its domain. So we are going to have our f of g of x. This will give us, this means that write the function of f where there is x, put your g of x. So this will be, we are going to have our f is equal to the square root, where there is x, we are going to put our g of x. That's the meaning. So we have our square root of our g of x is equal to 2x minus 1. So just as we said, whatever is inside the square root, it should always be greater than or equal to 0, so that it gives us a positive value. So we are going to just get to find the domain. So this is our f of g of x. So to find our domain, so we are going to have our domain, you are just going to get whatever is inside and say 2x minus 1 should be greater than or equal to 0. Take the 1 this side, we are going to have a 2x should be greater than or equal to positive 1. Divide a 2, divide a 2, we are going to have our x is greater than or equal to 1 over 2 like that. So we have found our domain. So our domain means to say, in interval notation, our x value, the smallest, it's 1 over 2. But if x is greater than 1 over 2, it means to say it can continue moving like that. Now we are here. For our c, we are told that our f of x should be equal to 2 over our x minus 1, and our g of x should be equal to 1 over our x like that. Now we are told find f of g of x and determine its domain. So now here we need to be very careful. You must look. The way composite functions work is, if you have your f of g of x, what you have is that, look at the one here. If g, whatever last letter you have, you look at it first. Does it have a condition upon which you cannot put a certain value? If it does, set that limit in advance. So we are going to have already, so if g was the first one to set gf of x, we could not look at the limit for g. So we only first look at the limit for the one that is being substituted into. So fg of x means write the function of f, then where there is x, put your g of x. So due to the fact that g of x is standing for x, that's why we even consider, does it have a limit? So already here you are going to say that your x cannot be equal to a 0 like that for g of x. So this is how we do it for composite functions. Look at the last part, the g of x. Does it have a condition? If it does, state it in advance because it will be part of your domain. Now if you compare it with this other one, you are going to find that we were told to find our fg of x. Now g of x is this one, it doesn't have a limit. But if we were told to find, let's say, our g f of x, that would mean to say, look at f of x. Does f of x have a condition before you can even state the domain? So the last letter, if it has a condition, you have to account for it. So it is the same principle that we are using here. So we are going to have so x should not be equal to 0. Now we can solve it. So this means that the function of f, which is our 2 over, we have, where there is x, put the function of g of x, which is our 1 over x, then we have minus 1 like that. So what we are going to have is that we have a 2 there. Let's factorize. Let's find the common denominator. We have x. So x divided by x, that's 1 times 1, it will be a 1, minus x divided by 1, that's x times 1, it will be x like that. So this is the same as having a value that is equivalent to a 2. Then we have divide by, we have 1 minus x over x like that. So this is the same as having 2 times our x over our 1 minus x like that. So let's multiply. So when we multiply, we are going to have our 2x over 1 minus our x there. So this function is our fg of x, fg of our x like that. So now, as you can see, the denominator can never be equal to 0. So therefore, you are going to say 1 minus x should not be equal to 0. So you are going to have, take the x the other side, so that you are going to have 1 should not be equal to x. So x should not be equal to 1. We also said, and also x should not be equal to 0. So the domain is such that all real numbers, x is a member of all real numbers, so real numbers such that x is not equal to 1 and x is not equal to 0. So this is our domain. It says that it can be written like this or in interval notation, of which we have a 0 on the number line, we have a 1 there. So to write the interval notation, write the regions which can be accepted. So we are going to have all the values that are this side are acceptable. So we can write we can go as far as negative infinity like that, comma, 0 is not allowed. So we are going to write 0 with an open circle like that. We combine it with union with, so all the values that are here from 0 to 1 are acceptable. So we have a 0 to 1. As you can see, I have used open circles to show that these, my 1 and 0, are not part of the solution. Then last but not the least, you are going to move from this one not included to a positive infinity. So all the values that are this side. So this is how you can write the interval notation. The mistake you would make is to write from 0 to positive infinity. If you write like this, you mean to say all the values from 0 to positive infinity are acceptable, meaning even 1 is included. If you just write from let's say negative infinity, you write negative infinity to 0, then you say union 0 to some infinite value, it means to say you are including. So you have to just write them, the three of them, in case it came to say write the interval notation. So the answer is negative infinity, comma 0, union of 0, comma 1, and union of 1, comma some positive infinites like that. So let's look at our D. So we have our f of x should be equal to 1 minus x squared. Then we have our g of x should be equal to the square root of our x like that. So what we are going to have is that let's find what our g of f of x is equal to. So now look at your f of x. Does it have a condition? So this is a quadratic, and the quadratic does not have any condition. So this means that write the function of g where there is x, put your f of x like that. So all we are interested in is the last letter mentioned having any conditions? If not, continue. So we are going to have, where there is g, we have the square root of, where there is x, put your f of x. So we are going to have the square root of our 1, then we have minus x squared like that. So this is our g f of x like that. So this is a difference of 2 squares. So now all we have to do is just get this, equate it, say it should be greater than or equal to 0. So it would be 1 minus x squared should be greater than or equal to 0. So this is a difference of 2 squares. So we are going to have 1 squared minus x squared greater than or equal to 0. So we have a 1 minus x. We also have a 1 plus our x. So this is a difference of 2 squares, and this is how it works. So it should be greater than or equal to a 0 like that. So from there, let's find our critical values. So our critical values, we are going to find our 1 minus x and our 1 plus x should be equal to 0. So it's either 1 minus x is equal to 0, or we have a 1 plus x is equal to 0. So we are going to get, if we get our x, we take it there, we are going to have 1 should be equal to x, or we are going to have, taking the 1 the other side, we are going to have our x should be equal to negative 1 like that. So let's come up with a table. So to come up with a table, we are going to have something like this. We have a negative 1, we have a positive 1. So all the values that are this side are less than negative 1. We could have negative 2, negative 3. So we are going to say all the x values here are less than negative 1. Then all the x values on the right of this, they are all greater than 1, because we could have a 2 here, 3, 4, and so on. Then all the values that are in between are such that this value is greater. So our negative 1 is less than x, while the x value is less than the last boundary, which is our 1. Let's come up with a table quick. So we are going to have our factors. Then we are going to write our factors, which are these: 1 minus x and 1 plus x. So 1 minus x and 1 plus x like that. Then we are going to say a product, since they are multiplying. Then let's write this interval. Our x should be less than negative 1. Our negative 1 should be less than x less than 1. Then we have our x should be greater than 1 like that. So finally, what we are going to get is that if x is less than negative 1, that means to say our x is equal to a negative, it could be equal to a negative 2 or negative 3 if you want. So here x is equal to, from negative 1 to 1, x could be equal to 0. From to the last one, we have our x. If x is greater than 1, it can be equal to a 2. Let's replace. So when we get our 2, we put it there. We are going to have a 1 minus negative 2. So this is going to give us 1. This times this, we are going to have positive 2, which will give us a positive 3. So let's write our positive there. So we are here. We get this negative 2. We put it there. We are going to have 1 minus 2, which is equal to -1. So we put in a negative, then positive times negative, it will be negative. We get a 0. If we put it here, it will be 1 minus 0, which is 1. So we have a positive there. If we get a 0, we put it here, we are going to have 1 plus 0, which is a positive. Then we are going to have a positive when we multiply this and this. Then when we get a 2 here, we are going to have a 1 minus 2, which is equal to -1. So in this case, we are going to have a negative there. Then when we get our 2, we put it here, it will be 1 plus 2, which is equal to 3. So we are going to have positive. Negative times positive, we are going to have a negative. Then according to what was being multiplied, we are told that our 1 minus x times our 1 plus x, it should be greater than or equal to 0. So let's take the sign where it is positive, because the positive is the one that is greater. So the values are such that we have a -1 should be less than or equal to, x should be less than or equal to 1. So we have included this because it's showing here. So we have this as our answer. In terms of interval notation, this means that an open circle, meaning include the -1 to +1, like that. So with that type of a circle. So this is how we do it. Let's finish up. Our f g of x. Now look at your g. First look at your g. First let's write them. So f of x is equal to 1 minus x squared. Then our g of x should be equal to our square root of our x, like that. So now look at your g. Does your g have a condition? So if g is equal to the square root of x, since it is the last letter, look at the last letter. Does it have a condition? The square root of any number has got a condition. So you are going to say that the condition is such that get whatever is inside and say it's greater than or equal to a 0, like that. But be very, very careful. This only works if you have an even root. If you have the square root, if you have the fourth root, if you have the 60th root, you can just get what is inside and say it should be greater than 0. But if you have the let's say the cube root, you don't do this. So just in case you haven't watched that one, just kindly watch for finding the domain. Then we have found that. So now let's calculate this. So this means that write the function of f where there is x, write the function of g of x. So we are going to get a f is equal to, we have 1 minus, where there is x, put g of x, like that. So then square this, since it is x squared there. So you are going to square this. So we are going to have 1 minus our g of x, which is equal to the square root of x, then to the power of our 2, like that. So this one and this one cancel. So we are going to have a 1 minus our x. So it will be f g of x, which is equal to 1 minus x, like that. So this is how we go about that. As you can see, this is a linear equation, and the domain of a linear equation is always -infinity to +infinity, like that. So the only condition for this one, it's -infinity to +infinity, but g of x had a condition to say that g of x was found to be having the condition that x should be greater than or equal to 0. So therefore, since this one is more like it has got a lot of limitations, x should be greater than or equal to 0, therefore we are going to take this as our domain. So our domain are the acceptable x values that you can use throughout. So the domain shall be such that our x should be greater than or equal to 0 there. So this is how we deal with composite functions when doing domains. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.